I'm happy to introduce this school, GMB School on Biomedical Engineering for Sustainability. Welcome everybody, and I hope we're going to have a really good, fun and formative week, getting to know each other, collaborating with each other. It's a new way of learning and a new way of teaching for us as well. So my name is Arti Ahluwalia, and together with the team that helped organize this school, in particular Carmelo Di Maria, who you all know, I'm sure, Stefano Severi, who is sitting here in the front, and Leandro Pecchia, but I'm not sure where he is. He was around, he'll be here soon. So this will open the school, and I'll present the school to you. I'll present the way we're going to work together during the week to learn about sustainable development in bioengineering and learn how to work using collaborative design principles. So this school is going to be, at least for us and for a lot of you, a new learning paradigm in biomedical engineering. Not many of you have courses on sustainable biomedical engineering. Not many of you know about biomedical engineering regulations from what we've seen of the questionnaire. So we're going to be exploring this area together with the teachers and the mentors that you'll be meeting during the course of the school. And so we're going to go beyond the classic confines of biomedical engineering, what we learn at school, what we learn in our lectures, biomechanics, bioinformatics. It's going to be a new approach whereby we'll learn together with each other and try and mix our expertise and our interests to actually innovate and create. The course is based on the Sustainable Development Goals, and this is something you're going to learn about in one of the lessons. So you'll learn about the UN's SDGs, which were proposed in 2015, and which, as a community, as a world, and as in particular as a community of bioengineering and engineers, we're going to try and meet. I'll go into detail into a couple of them, and then Domenico Vito in one of the lessons will explain to you what exactly they're about. Okay, I'm trying to get my okay. So the aim of the school is to offer you a new perspective on how to design medical technologies, how to design them together, how to design them with safety as a first requisite, and also functionality, resilience, and context-based. Okay, so this is all about designing together and designing appropriate technology for different contexts, be it here in Italy, be it in the country that you come from, be it in developing countries that you might wish to collaborate with, and that I'm sure you will in the course of this school. You will find people from different contexts, and you'll find a lot of people from developing countries who are actually here to help you understand the needs that we have. So I'll introduce the community to you during the course of my my talk. So we're talking about sustainable development. So development that permits evolution, permits maintenance, permits handling, and permits the systems, the biomedical technologies to evolve and develop along with the local context. That's what it's going to be all about. So together we're going to define what functional means. So something that's useful in a specific context, in a specific time, during a specific need. And also resilient, which means that it's not going to break. Okay, so that's really important. It's not going to break considering the environmental constraints, considering, for example, blackouts, considering earthquakes, considering the lack of resources, for example, the lack of masks or the lack of safety devices or specific materials. That means that we must think about the resources that we have in the local context, and obviously that these resources have to be sustainable. So we have to know where to get them from if and when they break. That's what we're going to be learning about, and that's what we're going to be doing in a collaborative context. So we're going to put you together into groups, and you're going to work together to resolve questions, to resolve problems that biomedical engineers, doctors and patient space in their everyday lives in different contexts. What we've tried to do is we've tried to put you all together in groups from different backgrounds, from different cultural areas of the world, from different universities. We've tried to mix gender as well. And you're going to be working together on a 1-week project, okay? And I think there will be about 20 groups of 9 people working together. And at the end of the week, after you work together on your project, we're going to have you present what you've done, and we're going to select the best projects. Okay, so it's a sort of a context, a contest, a competition between you. There's no losers, there's no winners, there's a best project. There's 2 best projects, actually. There's a best project for those of you who are here at the school in presence, and then there's one for the students who have joined online who couldn't make it here. So we're going to guide you through the process. We're going to guide you through the development of medical technologies, and you will have time to work together and develop your projects in groups and then present them on Thursday afternoon. So it's going to be slightly different from the normal PhD school where you sit in the hall and you listen to lectures and you make notes. We're going to actually get you to do your thing, and then we're going to listen to you. Okay, so that's the difference in approach that we'll be using, and obviously we're going to be learning about new different things that you have never maybe affronted before. So what you're going to do is together identify an unmet clinical need, and we'll actually present some of these to you during the course of the week. So you'll see different contexts. You'll see, incubators, for instance, machines to help women during labor, machines for breathing, etc. And you'll see what the problems are. You'll see what the issues are. You'll see what the needs are, and you will then together develop technological solutions that might address these unmet clinical needs. And there are a lot of them. We'll be talking about them during the course. On Thursday afternoon, having worked together on your projects, we'll ask each group to present their results. Okay, so 5 minutes of pitch, and then we will select the best projects, and they will be they will be given a prize. So important is teamwork. You'll learn how to do that during the course of the week. But we've got mentors here. We've got people who know how to deal with technological problems. We've got people who are experts on medical device regulation. We've got people who are experts on diseases, infectious diseases, for instance. And we'll help you. We'll be there if you need us. We'll leave you our emails. We'll leave you our contacts, and you can ask us questions. We'll be around here. And there are many of us, you'll see us when we present our work to you. You'll also be using the Ubora platform as a guideline. So this is a collaborative design platform which has been developed by a group of biomedical engineers. And it's a platform that helps you to design safely, okay? Design together and design safely according to European medical device regulations. And that way, the concept of safety, the concept of applying standards to your designs, hopefully will become second nature as you go along, and hopefully you'll be able to use this platform in the future should you want to design devices in different contexts and for different scenarios. So that will be introduced to you during the course of the lecture. Some of you might know what it is already. So who are the mentors? Well, all of the lecturers in this book are mentors, and we've also got mentors that have come here specially from the African Biomedical Engineering Consortium. They're here because we're having a meeting together, but they're also here to help you and to give you ideas and to explain their contexts and their problems. I cannot see anybody. Maybe June Madete is here. So she's from Kenyatta University. and she's the head of the Department of Electrical Engineering at Kenyatta, and she's also a biomedical engineer with a lot of local experience. So, you know, go to her, ask her. I cannot see the others. I cannot see Dawit. I cannot see Caroline. I cannot see Yvonne. But when I see them, I'll get them to stand up and present themselves to you. So, you know, do ask them, do talk to her, do talk to them, and talk to June, because she's really great with her ideas and her enthusiasm. Having said that, you will see who you are, whose teams you belong to, so in which groups you are on the teaching learning platform. And as I mentioned, the teams have been created to encourage collaboration and encourage crosstalk and encourage the formulation of teams who have different backgrounds, different ideas, and different areas of expertise. There'll be teams with PhD students and master's students, and maybe even some lecturers and professors and professionals who have attended the school because of their interest in the topic. We will evaluate the projects on the basis of the identification of the clinical need, the way you implement your project technically, so the technical solutions that you propose, the innovation value of the technical solutions as well, and the way in which you present and document your project. So, you know, the way in which you choose standards, the way in which you apply standards, which standards you apply, and how you actually create your design. So, you know, is it a pencil sketch? Is it a nice CAD drawing? Which type of platforms did you use? We'll look at all those points, and we'll have a team of evaluators who will select the projects and grade them according to their adherence to these criteria that we've got here. Briefly show you the technical program, which we might update, and so you'll be able to see any updates online, because there are a couple of people who weren't able to get visas to come here, so it will be updated. So this morning we're going to talk about needs assessment and life cycle of medical devices, and then in the afternoon we'll introduce the Ubora platform to you, and you'll be able to look at certain case studies and then dedicate yourself to group work. Okay, so what we intend to do is have you do your group work in your free time, and your free time is after the school and just before dinner. So you will have that free time. You can't roam the streets and go for a drink. You have to work together. You can do that in a bar, but we expect you to spend the evenings from 5 to 8 working in teams. Okay, so it's going to be work the whole way. On Tuesday, we'll be talking about innovative approaches to designing medical devices for different contexts. And then again, the afternoons will be dedicated to group work, case studies, learning about the different platforms, learning how to design, learning how to choose standards, learning how to define regulations, etc. And again, Wednesday, you will have the mentors present innovative ideas to you. You'll be able to see them in the program, and then group work in the afternoon, group work, design, collaboration in the afternoon. Thursday morning will be dedicated to management of medical technologies. So, you know, how do you choose the technology? How do you decide who is going to be used for? How do you decide, even on the basis of economic constraints, how, when, and where you're going to apply these technologies? And then in the afternoon, we will dedicate that Thursday afternoon to the presentation of your projects. Okay, so it's going to be mornings learning, meeting the mentors, and afternoons technical work on your part, learning how to design together and having your meetings, working together for your case studies. So that's the program. Just briefly, you'll be able to see this on the platform. So this is the outline for today. So I'm going to just introduce very quickly some numbers, some data on the state of health in the world, and then you'll go on to learn about the SDGs, life cycle of medical devices. We'll have then a keynote lecture, And then in the afternoon, it'll be more on the operational part of medical device design. I'm going to go ahead quickly with this. It's similar setup. So the morning will be dedicated to case studies, to lectures on the theory. And then the afternoon, you'll be able to see some real technological solutions that have been applied in different contexts. For example, the case study of a low-cost balloon against maternal bleeding, and a system for pneumonia detection in LMICS, which means low and middle income countries or contexts. And then finally, on Wednesday, again, the same kind of layout, but here we'll be talking more about the bioinformatics part of medical device development. And finally, the Thursday will be on the management of medical devices. We'll have a small break for the GNB Award ceremony, which is a ceremony that the National Group of Bioengineers in Italy holds every year to give prizes to the best PhD thesis and the best master's thesis. And during that, you can attend the ceremony or you can work on your projects and prepare your presentations for the afternoon. Okay, so having said that, I will close this presentation of the school and thank the sponsors and the support groups that we've had. So thank you very much to the IFMB, the International Federation of Biomedical Engineering, which has contributed to many of the people coming here. So they paid for the travel and the hotel for many of the people attending this conference. The EAMBS, the University of Warwick as well. They've also contributed financially to having many of us here. And finally, the Ubora Association. So the Ubora Association, I'm happy to announce, was born today, or has become a legal entity today. And within the next few months, you will be able to join the association as a student or as a staff member or as a biomedical engineer and contribute to collaborative design, as you will see as we go along. So happy to announce the birth of Ubora as a legal entity. So that means we can go forward with this idea of creating a new community of biomedical engineers and really help with promoting health equity, promoting the accessibility of healthcare to everybody.